Hello everyone, this is Ishrat Jahan Ibha. In this video, I will discuss the basic concept of elasticity and price elasticity of demand. So, let's begin with elasticity. Elasticity is the measure of responsiveness of one variable, such as quantity demanded, quantity supplied, to a change in another variable, such as price, income. The basic formula of elasticity is percentage change in dependent variable divided by percentage change in independent variable. For example, percentage change in quantity demanded divided by percentage change in price. The meaning of elasticity referred as for 1% change in independent variable, how much change occurs in dependent variable. If we consider elasticity as the function of x and y, where x is the independent variable and y is the dependent variable, we get the ratio of elasticity as percentage change in y divided by percentage change in x. Or elasticity is equal to delta y by y times 100 divided by delta x by x times 100. This equals delta y divided by delta x into x by y. That means elasticity is the multiplication of absolute change and the base of the variables. Now we'll learn about the price elasticity of demand. Price elasticity of demand is the measure of the responsiveness of quantity demanded to a change in price. According to the concept, formula of price elasticity of demand equals percentage change in quantity demanded divided by percentage change in price, or change in quantity demanded by quantity demanded times 100 divided by change in price by price times 100. And finally, we get the formula change in quantity demanded divided by change in price into price divided by quantity demanded. Here are the indicators of this formula. Epsilon D is the coefficient of price elasticity of demand. Delta QD refers to absolute change in quantity demanded. Delta P refers to absolute change in price. QD is the average quantity demanded that equals Q1 plus Q2 divided by 2. And P is the average price that equals P1 plus P2 divided by 2. Price elasticity of demand is measured by some determinants such as number of substitute goods, degree of necessity, share of budget, and time, etc. By analyzing the behavior of these factors, we can determine how the elasticity will be, more or less elastic. Let's take a deeper look by exploring the types of price elasticity of demand. Price elasticity can be 5 types: elastic, inelastic, unit elastic, perfectly elastic, and perfectly inelastic. Let's find out one by one. The first demand curve shows that when 10% price increases, the quantity demanded decreases by 12%. That means when percentage change in quantity demanded is greater than the percentage change in price, the demand is called elastic. The coefficient of price elasticity of demand is greater than 1 because the quantity demanded is higher than the price. The more flatter the curve is, the more elastic the demand will be. In the second curve, we see the 10% increment of price makes 4% reduction in quantity demanded. That means when percentage change in quantity demanded is less than the percentage change in price, the demand is called inelastic. And the coefficient is less than 1 because the quantity demanded is lower than the price. The more steeper the curve is, the more inelastic the demand will be. The next graph depicts 10% increase in price and 10% reduction in quantity demanded. So, when the percentage change in quantity demanded is equal to percentage change in price, the demand is called unit elastic. In this case, the coefficient is 1 since the quantity demanded and price is equal. Now, have a look on this graph. Here, at the initial price OP1, the demand is infinity. If the price is slightly decreased, it leads to an increase in demand by a large amount. So, when a small percentage change in price causes an extremely large percentage change in quantity demanded, the demand will be perfectly elastic and the coefficient is infinity. And the last type shows, though the price increases by 10%, still there is no change in quantity. So, perfectly inelastic demand is the demand that occurs when quantity demanded does not change as price changes. Here, the coefficient is 0. Perfectly elastic and perfectly inelastic demand is a theoretical concept and cannot be applied in practical situations. Remember, by convention, we always talk about elasticities as positive numbers. Mathematically, we take the absolute value of the result. In this section, I will be discussing about the arc elasticity method of measuring elasticity. Arc elasticity is a measure of elasticity that averages the percentage change in quantity demanded or quantity supplied between 2 points on a demand or supply curve relative to the change in price. This method is used when there is a substantial change in price. Let's consider a demand curve. Here, the price decreases from P1 to P2. As a result, the quantity increases from Q1 to Q2. Remember, the arc is the portion between R1 and R2 of the curve. By this method, we measure the elasticity between these 2 points, not in R1 or not in R2. Therefore, the coefficient of arc elasticity of demand stands percentage change in quantity demanded with respect to midpoint divided by percentage change in price with respect to midpoint, or Q2 minus Q1 over Q1 plus Q2 by 2 divided by P2 minus P1 over P1 plus P2 by 2. After arranging the formula, we finally get the equation P1 plus P2 divided by Q1 plus Q2 into Q2 minus Q1 divided by P2 minus P1, where P1 Q1 represents the original price and P2 Q2 represents the new price. And we will always get a negative value of the result because of the inverse relationship between price and quantity. In the previous slide, we learned how we can measure price elasticity with arc elasticity method. Here, we will study another method of measuring elasticity, that is point elasticity. Point elasticity is the measure of responsiveness of the quantity demanded or supplied of a product to its price variation at a particular point on the linear demand or supply curve. This concept is important when the change in price and change in demand is infinitesimally small. Suppose we have 5 different points on a demand curve. Point A, B, C, D, and E. A is the midpoint of this line. At each point on this straight line, we can measure elasticity by this formula. Point elasticity equals lower segment divided by upper segment. Starting from point A, the lower segment is AE and upper segment is AD. So, we get AE divided by AD. Since A is the midpoint, AE is equal to AD. So, the coefficient of point elasticity equals 1. At point B, the lower segment BE is less than the upper segment BD. So, the coefficient of demand curve will be less than 1. Similarly, at point C, the lower segment CE is greater than the upper segment CD. Hence, the coefficient of demand curve will be greater than 1. Thus, at two marginal points D and E, the coefficient of demand curve is infinity and 0 respectively. Remember, at any point between A and D, the demand will be elastic. Between E and E, it will be inelastic. And at the midpoint, the demand is unit elastic. Let's find the solution of a question. This is obvious from the graph that it is a demand curve of price elasticity where X and Y are 2 points on the curve. The graph shows that price increases from Taka 400 to 600. As a result, the quantity decreases from 12 to 10 units. We have to determine how the demand will be between X and Y. The demand can be determined by finding the coefficient of price elasticity using the midpoint formula. As we know from the previous slide, PED equals delta QD over delta P into P over QD. Here, delta QD is the difference of quantity, that is 10 minus 12, and delta P is the difference of price, that is 600 minus 400. P is the average of the price, that is 600 plus 400 divided by 2, and QD is the average of the quantity, that is 10 plus 12 divided by 2. After calculating, the result is 0.45. As the coefficient is less than 1, the demand between X and Y will be inelastic. Here is an important topic: elasticity versus slope. Some people think that elasticity and slope are the same, but actually they are not. Let's prove it by calculating both the elasticity and slope. Suppose we have 3 points A, B, C on a demand curve representing their respective price and quantity. If we move from point A to B, we get the elasticity minus 0.71 after calculation. And from point B to C, the result is minus 0.33. Notice that we get different elasticity on different points. Now, between point A and B, the slope is minus 0.5, and point B and C, we get the same slope. So, the difference is clear. Elasticity is the ratio of percentage change of two variables, but the slope is the ratio of absolute change of the two variables. And at every point, elasticity of a curve changes. On the other hand, the slope remains constant. That's all from today's video. Thank you everyone for staying with me.